Today we're going to be talking about how do we solve a linear system graphically. So let's talk about what that means. First of all, what is a system of equations, okay? A system is when you have two or more equations, when you're looking at them together at the same time. And linear, we know, means straight line, right? So that means straight. So when we say we have a linear system, it says exactly what I have here. It's two or more straight lines that we're looking at once, okay? So that's it. So we can have 2 lines, 3 lines, 4 lines, okay? So on and so forth. But today we're just going to be looking at 2 lines. So it's nothing we haven't done before. We've graphed 2 lines. Really, this lesson is just review. If you know how to graph lines, it's easy. You can do it in a few minutes, right? Just knowing some definitions and things like that. Okay, so what's the solution then to a linear system? Okay, the solution of a linear system of 2 equations or more, and like I said, we're just going to look at 2 equations, is the point at which these graphs intersect. Okay, so the point of intersection. So it's the point where they're the same. So looking at this example one, it's already drawn for us. Okay, here is 2 equations that are part of a linear system. And what is the solution to that system? The solution is -2, -4, which would be right here on our graph, right? -2, -4. So it's just the point where they intersect, okay? And that's what a solution is. So for it to be the solution, it has to satisfy both equations. So what does that mean, satisfy? So I mean, graphically, we can see it's the point of intersection. Think about it this way. Let's look at each equation individually. Let me look at this first one here. Y equals 1/2 times x minus 3. Y equals 1/2 x minus 3. Well, what if we substitute in the x coordinate here, right? The x coordinate is -2. So let's replace the x with -2. All right, so what do we get for y? Well, 1/2 of -2 is -1, and -1 minus, -1 minus 3, I'm jumping my answer too quick, is -4. Notice how that's the y coordinate here. So that means the point -2, -4 is on this line. So how did I prove that it was on the line? I subbed in the x coordinate, I found out the y coordinate, and I found out that this point works, right? When I sub in -2, I get out -4. So that tells me that this point is on the line. We can do the same thing with the other equation, this guy right here, right? X plus y equals 6. Why don't we start by rearranging that equation? Remember, anytime we have an equation that's not in y equals mx plus b form, if it's in standard form or different form, we want to rearrange it. So to put in y equals mx plus b form, we're going to minus x from both sides, and I'll get -x minus 6, right? Now, what happens when we substitute -2, again, in for x in this equation? So y equals negative times -2 minus 6. Well, negative times -2 is +2, and +2 minus 6 is -4. So notice, again, when we make the x coordinate -2, the y coordinate ends up being -4. So it works. So that point is also on that line. So if a point's on both of those lines, it must be the point that they intersect at, right? So graphically, we can see that right here. Yeah, that point is there. That point is there. It's the same point, so that's the point where they intersect. And that's what we mean by a solution. So graphically, a solution is just the point of intersection. Algebraically, it's the point that satisfies both equations. When we sub in the x, we get out the y. All right, so we're going to just basically practice graphing a couple lines, making sure we can find the solution. And again, most of the marks in this whole thing is about, can you properly and accurately graph these equations? Not just find the point. Really, you're getting credit for doing a good job graphing. This is kind of your final test on graphing lines. We've done a lot for several months this year. This is the end of it, and this is your final challenge. How neat and accurate can you make these graphs? Okay, so we're going to look at 2 equations here, and the question says, determine the solution to the following linear system. So again, linear meaning straight lines, and system just meaning we're looking at more than one equation. So we got 2 equations here. So let's start with this one right here, y equals 2x minus 7. Now, how do you graph it? That's up to you. Remember, we have 2 options. One option, you can make a table of values, right? And you can pick numbers for x, like 0, 1, 2, so on and so forth, and sub them in. So if I take 0 and sub it in for x, what's 2 times 0 minus 7? 2 times 0 is 0. 0 minus 7 is -7. So I can do it that way. So 0, -7. And then find more points. You want to sub in 1. 2 times 1 is 2. 2 minus 7 is -5, right? So I'm 1 over -5, and you can keep doing that, right? Let's do another point. Let's do 2. 2 times 2 is 4, right? And again, I'm just substituting into the x there. 2 times 2 is 4. 4 minus 7 is -3. right? And so on and so forth. And we should see that linear pattern. Notice how it's linear. Every time I go up by 1 on this side, notice I'm going up by 2 on this side, right? So you can figure out the pattern pretty quick as long as you keep a pattern on this side, right? So I know the next one, if I put in 3, the next one's going to be at -1, right? Because I'm going to go up 2 again. All right, and so on and so forth. Okay, so that's one way of doing it. Or remember the shortcut method if you want. The shortcut is, this is in y equals mx plus b, so b is -7, right? So that's my y-intercept, right? My y-intercept is b. So we already can see that in our table. If b is -7, there we go. Then the coordinate 0, -7 are the coordinates of our y-intercept, which is right down here, right? 0, -7. So we already graphed that. Okay, so we got that point on there. And then I can use my slope, right? Remember how the slope in this case is 2, right? But if it's 2, it's really 2 over 1 because it's a fraction, right? And the rise is +2. We're going to go up 2. And the run is +1. We're going to go to the right 1. So we're going to go starting here, right? We're going to go, and we already have a lot of these points on it, but like up 2, right? Rise of 2, run of 1. Rise of 2, run of 1. Rise of 2, run of 1. We can keep doing that. Rise of 2, run of 1. Rise of 2, run of 1. Rise of 2, run of 1. And keep finding points that way. So I'm just going to take those stairs off. Oops. And I'm just going to draw on those points. So rise of 2, run of 1. Rise of 2, run of 1. And you get the same graph no matter which method you prefer. Now I use the second method because it's a little quicker. Remember, I can also go backwards, right? Put a point here. There we go. So the points should all be in a straight line. All right, so get out your ruler, right? Being able to graph a line is essential at this point. It is mandatory to move forward, okay? So draw a line through it, right? There we go. Make sure it's really accurate. When you're doing it, by hand, get your ruler out. Really carefully go right through the center of those grid lines. It's pretty darn good there. Make sure the lines go past the grid. Notice just like this. Notice how those arrows go beyond the grid lines. So draw your arrows beyond the grid lines. And at one of the ends, label it with the original equation. So the original equation was y equals 2x minus 7. So I'll just label it up here. Y equals 2x minus 7. All right, there's our first equation. Let's do the second equation here. All right, so this one here, 2x plus 3y minus 3. So the obvious problem, hopefully at this point, is this is not in slope y-intercept form. It's in standard form. So we need to rearrange this to isolate the y. So how do we do that, right? We move everything that's not a y term to the other side. So leave the 3y there and move the 2x over by subtracting 2x from both sides. So we'll get negative 2x. And we're going to get rid of that. And get rid of the negative 3 by adding 3 to both sides. And there we go. And then we got to get rid of this 3 here. So right, what do? We divide both sides by 3. And we have to divide each term by 3. Everything gets divided. And here we go. Y equals negative 2 over 3x plus 1. Now, if you want to make a table of values for this one, go back, watch all our old videos. We've done a lot of it. But let's use the shortcut. It's just so much faster. What's my y-intercept? Well, my y-intercept is b. And b is 1. There's b right there, right? So b is positive 1, so my y-intercept is 0, 1. 0 over 1 up. There's the coordinates of my y-intercept. Now, what's the slope? The slope is a fraction already, and it is negative 2 over 3. So it's negative. We should be going down, right? Our line should look more like this, where if our slope is positive like the other one, the line is going up from left to right. So we're going down from left to right. We're going to go down 2, but over to the right 3. So starting here, let's go down 2 steps, 1, 2, and over 3. And we land right there at our point of intersection already. Down 2 over 1, 2, 3, down 2 over 1, 2, 3, right? And I can reverse the steps by going backwards 3, up 2, backwards 3, up 2, backwards 3, up 2, backwards 3, up 2, and so on and so forth. All right. So, but I started here. That was my starting point, right? Now, again, yes, we found the point of intersection, but most of your credit, like if this was, let's just throw 10 marks, 9 of the 10 marks are to graph the lines properly and do a neat job. That's really what you're getting marked on at this point, okay? It's kind of your final test. Can you do a good job drawing lines, right? That's really what I'm looking to evaluate. Extend the lines past the grid, put some arrows on the end, that you actually do a neat job. You use a ruler, you don't freehand it, right? And the only point that I need you to label on it is I want you to make it really clear what the point of intersection is. And write POI next to it for point of intersection. That's just short for point of intersection. And what do we have here? It's 3 over, 1 down. So if a question says, what's the solution? We can also state, I'll just write at the bottom, the solution, SOLN is short for solution, is 3, negative 1. There you go. That's our solution. It's our point of intersection. Okay, oh, and I didn't label it, the equation, I forgot to label. So when you label it, you should label it the original equation. So the original equation was this. It was in standard form, right? So let's just label, I'll label it this end right here. 2x plus 3y minus 3 equals 0. There you go. There's the original equations, drawn neat, okay? Let's just do one more because I want to talk about another situation you might run into, and then that'll be it for this lesson. Okay, I've got one final example because we've done so many lessons this year already on graphing lines. At this point, I'm hoping it's pretty second nature to you. You can even go back and watch the videos I made earlier in this unit about graphing lines to review. Let's start with this line, x equals 6. And hopefully at this point, you know, if you're moving to grade 10 academic level, this should be ringing some bells. X equals 6 is a problem, right? That's not a standard equation. It's not in y equals mx plus b. There isn't even a y. It's just an x. So at this point, we got to recognize our two special cases, right? This is a special case. Okay, anytime there's only an x, right, it is a vertical line. Okay, so it's always a vertical line. If we make a table of values for us, we've done this a lot this year, right? This is, in this case, since it says x equals 6, the x-coordinate always has to be 6. There's no choice. So if you make a table, you can make y anything you want. 0, 2, 100, right? Negative 1,000. I know that won't fit on our graph, but so on and so forth. Negative 3, that would fit. Okay? Now, the quick way, again, you just kind of need to really memorize this and learn it. It's a line you're going to see a lot. Vertical lines are just x equals, right? Go back and review, watch the videos if you forget all the definitions and explanations why. All right, so it's a vertical line. The quickest way is you go to your x-axis, you go over to 6. There's 6 on the x-axis right there, and you just draw a vertical line straight through that. And there you go. So the nice thing is they're really quick if you know what you're doing, right? If you don't know what you're doing, they're a little more difficult. All right, so don't forget to put your arrows at the end and label it at one of the ends. Done, okay? Now don't forget, if this had been, I'm just going to write it here, it's not going to be the case, but if I had given you the equation y equals 6, right? That would have been a horizontal line, right? And I'll just draw what that looks like on the graph, even though it's not in the question, okay? Just so we can get an idea. Horizontal line, if we made a table of values, right, same idea. In this case, the y's would always have to be 6. It doesn't matter what x is. So you can make the same thing, x0, 1, 100, negative 3, whatever, negative 10. So if we drew that line, I know it's not there, but I'm just going to add it in. It would look like this, okay? All right, so draw a line through there. Just want to review both of those one final time. So that's what x equals 6 and y equals 6 look like. All right. Now, let's go to our second line, though, our main line here. Okay, so those guys are pretty easy if we know those are our special cases. This guy here, though, there's an x and a y in it, so it's not a special case. Okay, special cases, horizontal and vertical, are only if there's only a y or only an x. If it has an x and a y, it's not a special case. But this is, once again, in standard form. So we need to change it to slope y-intercept form. So how do we do that again? Remember, we leave the y term on this side. So I'm just going to leave the negative 2y here for now. And I'm going to get rid of the 3x by subtracting 3x to move it to the other side. Get rid of the negative 14 by adding 14. And then I'm going to divide everything by the coefficient of y, which is negative 2. All right. And we have y equals, right? This cancels. Negative and negative cancel. So that's just going to be positive 3 halves x. Positive divided by negative is negative. 14 divided by 2 is 7. All right, so now, how are you going to graph it? If you like to use the table, go for it, right? But let's use the shortcut because it just makes life so much easier over the next few years if you get better at this, right? The y-intercept, that's the b. Well, what's b? b is negative 7. So our y-intercept is at 0, negative 7 again, down here. There it is. All right, what's the slope? The slope is like a set of directions for us, right? Tells us the steepness of the line. That's the m. Well, slope is positive 3 over 2. So it's positive. My line should be going up from left to right like this. All right, so we have a rise of 3, right? That's our rise, and a run of 2, going over 2. So starting at that y-intercept of negative 7, let's go up 3 steps, over 2, and put a point. Up 3 steps, over 2, and just keep that pattern going. Up 3 over 2, up 3 over 2, up 3 over 2, and there we go. And you can even go backwards 2 and down 3 if you want to find every single point. All right, so let's draw our line through those points. Take an extra second to really line your ruler up carefully to go right through the center of those grid lines, and put your arrows on the end. And at the end, label it with the original equation, which was 3x minus 2y minus 14 equals 0. Okay, and label your point of intersection. So our point of intersection was right here. So the POI, which is short for point of intersection, is 6, 2. So again, you can also state that the solution is, I'm just going to write SOLN for solution, is 6, 2. There you go. All right, now again, remember, most of the marks come from the graph, not from finding that point of intersection. Now, if you want to know what's the solution with that line and y equals 6, well, I'm not too sure what that coordinate is, right? I'd have to do a little more math to figure it out. So that shows there's a bit of an issue with graphing. What if it doesn't land on a really nice spot? What if it lands on a point like this? And you're like, well, what is it? You have to guess. Is it approximately this, right? That's going to be the next lesson. The next lesson, I'm going to show you how can we find that algebraically instead. Okay, and that might sound a lot harder than it is. It's not too difficult. Okay, so that's it for this lesson. Your homework for this is to graph some lines neatly, do the best job you can, and find the points of intersection. Make sure you label them. So just follow all the steps I did in here. Label stuff the same, okay? All right, thanks for watching.